You place your dying phone on a wireless charging pad, but wake up to find the battery icon still red and the device uncomfortably hot. Despite marketing promises of 15 or 25 watts, the real-world performance often drops to a slow, heat-heavy trickle. This graphic illustrates the divide between expectations and reality. The pad gets the blame, but failure happens inside the power pipeline. Look at the bottlenecks. Mismatched hardware, underpowered adapters, and physical misalignment create a chain where one failure caps the system's speed. Ignoring the mathematical requirements of wireless charging leads to wasted energy and accelerated battery degradation for very little convenience. Before looking at wattage, we must respect the physics of inductive charging. Energy has to jump an air gap between 0 and 5 millimeters. This diagram shows how case thickness alters efficiency. A 3 mm silicone case allows optimal flow, but a 5 mm rugged case forces the system to struggle, generating heat. Insert metal, and foreign object detection terminates power to prevent a fire hazard. The most advanced charging pad is useless if the physical gap is obstructed. Clearing the z-axis is the first requirement of the equation. The second requirement is at the beginning of the power pipeline. Your wall adapter provides the foundational input for the entire system. This schematic tracks a premium pad plugged into different wall adapters, which dictates output. Using an older 18-watt adapter constricts flow, delivering a maximum of 11 watts to the phone. To reach a 25-watt peak, the pod requires a modern 30-watt USB-C power delivery adapter. Check your existing USB bricks. If they are older 5-volt USB-A models, they cannot provide the wattage needed for fast wireless charging. A high-end wireless charger is limited by the capabilities of the adapter plugged into your wall. These power requirements become even more strict if you use a 3-in-1 dock for your phone, watch, and earbuds. This breaks down power negotiation for shared inputs. Powered by a standard 15-watt adapter, the dock splits the load, leaving the phone with only 7 watts and accessories 3 each. Allocating enough wattage to all zones requires a 30-watt or 60-watt adapter. Consolidating cables is only a benefit if you scale up your total power input to match the combined demand of every device on the pad. Now, where the charging pad actually meets the phone, we have to look at the magnetic power profile, or MPP. This schematic contrasts charging alignments. With standard Qi pads, manual placement causes misaligned coils, efficiency drops, and excess energy becomes heat. Conversely, Qi2 and MagSafe standards use a magnetic ring to force precise geometric alignment, facilitating optimal 15 to 25 watt energy transfer. This is important because smartphones actively monitor temperature. If the system generates heat waste, the device will initiate thermal throttling, often capping the charge at 80% to protect the battery. Precise magnetic alignment acts as a mandatory engineering safeguard, preventing the heat waste that triggers these thermal throttling algorithms. There is significant confusion around high-end Chinese flagships that claim massive 50-watt wireless charging speeds. Brands like OnePlus and Xiaomi use proprietary protocols like AirVook that operate outside the unified WPC standards. This flowchart shows the penalty of placing these phones on standard Qi2 hardware. Unable to complete the proprietary handshake, the generic pad drops to a 5-watt trickle. Accessing the full 50-watt output requires official hardware with active cooling fans to manage extreme thermal loads. For these brands, ignoring the proprietary ecosystem means sacrificing speed entirely. We can bring all of these variables together into a single, actionable formula for your setup. This equation outlines the specific components required to reach maximum wireless speed. The chain requires a certified Qi2 or MagSafe pad, a 30-watt or higher USB-C power delivery adapter, and a magnetic case to ensure MPP alignment. Removing or downgrading any single element immediately reduces the entire system to its lowest common denominator. This graphic warns against hardware using marketing terms instead of official certification. Official Qi-certified products are lab-tested for safety and foreign object detection. Products labeled only as Qi-compatible are unvetted and carry higher risks of overheating. Consistently achieving maximum wireless speed requires strict hardware discipline across the entire charging chain. To finalize a purchasing decision, you have to map this equation to the specific device in your pocket. This matrix cross-references smartphones with their limits. iPhone 16 users require a Qi2 25-watt pad and 30-watt adapter for peak capability. Samsung S25 devices lack built-in magnets and must use a certified magnetic case to enable 25-watt speeds. If your setup is currently underperforming, this decision tree provides a rapid-fire troubleshooting roadmap. Check for the 80% thermal pause, verify your wall adapter's rated wattage, and ensure no metallic debris is triggering the safety alarms. Convenience in wireless charging depends on technical discipline. Once you align your adapters, cases, and certifications, the system works as intended.